Hello and welcome. I'm Davis DeWitt, and this is a weird-looking clock. Now, recently I found myself with a lot of free time due to the film industry shutting down this summer, so I figured what better way to spend my unemployment than tinkering with some Soviet-era electronics. Oh, also I moved, which is why everything looks different. Now, as any good tinkerer would, I was exploring my local electronics store, and I came across this weird-looking box. Now, at first glance, there doesn't really seem to be much going on here, just some circuits and wires, but if you look closely, there's actually 4 original Nixie tubes inside of here. And if these work, this is a great find. Now, downside is, without the original component that this connects into, I don't really know what it does. Perhaps some of you can enlighten me. However, I can still use this for something else. I used to go dumpster diving as a kid, and sometimes you find stuff that looks cool but doesn't really work. And in this case, I think we can turn this into a clock. So even though it won't be serving its original purpose, I think it'll now at least have something better to do than just collect dust on a shelf. All right, Professor Davis is here because we have to pause for a second so I can explain what are Nixie tubes. Otherwise, the rest of this video is not going to make any sense. So, at their core, Nixie tubes are essentially really small neon signs. And you have a glass bulb filled with neon gas so that when a voltage is applied across a single grid-shaped anode and one of 10 number-shaped cathodes, the respective digit glows. Now, to fit all of those digits inside of the bulb, we have to stack them one on top of the other, and the result is a cool 3D scrolling effect when you cycle the digits from 0 to 9. Now, of course, modern display technology has rendered all of this completely obsolete. However, I think they're really pretty. And they're kind of rare now, considering that manufacturing for these ceased almost 40 years ago. So, if you get your hands on some, it's kind of fun. Anyways, back to the build. Now, before I can start taking this apart and see what makes it tick, I need to actually start working on the back end of this project first. So I've got some digital components here, and I'll show you what they are and what they do. First up is the driver board that will connect the individual Nixie tubes to the microcontroller, allowing us to control each digit of the clock. Next is the high voltage transformer, which provides the 170 volts needed to ignite the neon and make the tubes glow. Following that is our real-time clock module, and as the name implies, this device ensures the clock always keeps accurate time. Then of course we have our Arduino Nano microcontroller that makes up the heart of this project, and last but not least is the miscellaneous wires, buttons, and leads that will connect everything together. So, with everything laid out, I can start assembling all of the components and uploading the code that will make our Nixie clock work. Now that the internals are finished, it's time to move on to the actual teardown of our old computer module. And this step always makes me a little bit nervous because stripping down old electronics is rarely a straightforward process. However, fortune favors the stupid, so let's get into it. One thing to note here is that while this module has likely been sitting for years, Nixie tubes are cold cathode devices, which, unlike an incandescent bulb, means the filament doesn't get burned up over the life of the device. So in theory, they probably still work. However, that's of course assuming they weren't dropped, shaken, or stirred at any point in the last, 30 years. Oh, and on top of that, almost every bolt in this thing has completely seized in place, so I have to carefully drill each one out to finally get inside and extract the tubes. Well, I have good news and bad news. Good news is there are Nixie tubes in here, but I guess you have to be careful what you wish for because these are dual anode Nixie tubes, and I need single anode Nixie tubes. Now, the way that works is that normally you have a single anode and then 10 cathodes, and as you make the connection between each, you have 0 through 9 digits. But with dual anode Nixie tubes, you have 2 anodes and 5 cathodes. 1 anode for even and odd, and then the rest connect to the even and odd digits. Basically, that's a lot of talk to say that I need to swap out my Nixie tubes, and that's such a bummer because the whole reason I took this project was the fact that I found Nixie tubes in the wild. So even though it's not going to work, it looks like the rest of the housing is, and I have decimal lights in here that I can use as my colon for the clock. So I'm going to keep trucking along and try and find some replacement tubes, but until then, I'm going to have to put this whole project on hold. Now, before I get the new tubes, I want to show you what makes up the inside of this module, and it's these individually packed Nixie housings. The idea behind these being you could use the disconnects on the back to swap out the entire module if any of the electronics inside die. To do that, you just simply pull it out, replace it with a new one, and you're all set. Now, inside each one of these modules, we have our main Nixie tube here, and then a bunch of pins on the back that go into these connectors. And what these are for is transferring power and data from our selector knob up front and then a lot of the logic is actually handled inside of this driver board. Now, once you remove the Nixie tube, you can actually see our decimal light here, and these are just little tiny neon lights. There's two little elements here, and then these are usually filled with neon gas and glow. And then, hopefully, once I get the new Nixie tubes, I can swap out this housing right here for a new one, and then wire it into our driver board. So, here we are, 4 months after I started this project, and I finally have my replacement Nixie tubes. Now, sourcing these was an enormous pain in the ass, because like I said before, they don't really make Nixie tubes anymore. As a result, all the available stock is pretty much exclusively in former Soviet bloc countries. And as some of you might recall, that part of the world is a little preoccupied at the moment. But now that I have the replacement tubes, I can continue wiring up the rest of the clock and get these bad boys mounted into their new home. For this stage, I tried to keep my modifications to a minimum so as to maintain the original look and feel of the module, while still integrating as many of the features into the clock as possible. To mount the microcontroller, I built a small proto board that also housed the buttons and RTC chip, so that I only had to run one cable in the driver board. With all that complete, I could finally mount everything in place and reassemble the housing around the new components. Well, like most of my builds, it's 2 o'clock in the morning, but I have finally finished this project. And now comes my favorite part, where I get to turn everything on and show you what it looks like in its final form.
1, 2, 3, 4.
Now, I am of course bummed that I wasn't able to use the original tubes on this project, but my goal is to design the circuitry needed to make them work so that I can eventually use them. Nonetheless, I'm very happy with how this resto mod turned out, especially considering I was able to integrate a lot of the original features into the clock, like the decimal lights, power switch, and indicator light. Plus, I'm just glad this old brick got to live a new life instead of just getting turned into scrap. And personally, I think there's a lot we can learn from old technology besides just turning it into cool art. Now, for the second phase of this project, I've decided to design my own set of Nixie clocks completely from scratch, so stay tuned for that project. And, as always, thank you so much for watching.